Thanks, Mike. Yeah, I'm here with Eric Perkins from Starrett, and as we said, this is the Starrett FMS-1000 force measurement system. Is that?
That's correct, Dirk. This is our new FMS-1000, or equivalent of 225-pound test frame, tablet-based, as you can see. Let me go over some of the features that we have here.
Sure.
And kind of give you a little background on what we did and why we did it. Okay.
Okay.
First things that you'll notice is Granite Base. Granite does two things. One, it gives you a stable platform to work from, and it also provides weight. You're probably thinking, why would you want to put weight to a force tester machine?
Pretty tall column here.
Well, yeah. Well, it's right. It's because of the column. They tend to want to tip over. The taller they get, the more tippy they want to be. So for safety's sake, we put all the weight at the bottom. Okay. As one of the new design features we did is we did an innovative crosshead. As you notice, the crosshead wraps around more than the traditional comes straight out the front on most force measurements systems. So it wraps around. It gives you a much more stable crosshead that doesn't give you any flex in here.
Oh, cool. Because with the other method, I'm assuming what might happen is you got to higher forces, the head itself is going to start to
That's correct, Dirk.
deflect.
What you have is you've basically got a big C, and then you put the sample in between the C.
Yeah.
And in inherent design, it wants to be a little flexy.
Okay.
So this is the main reason why we did it. Extruded column in here.
So a single piece then?
Single piece column, yes it is. And what we've done on that is we've basically put all the electronics in the backside. Makes it very simple and easy to service, and that's one of the things that you want in the field is you want to make sure you be able to service stuff very quick and easy. The ball screw inside is a very high accurate ball screw, and it has no backlash to it. And that's something that you're looking for when you do testing.
Now, just to kind of set this up a little bit here, when we're talking force testing, is it tensile? Is it compression? What
it's
are we
both.
talking?
It's both. This system will do many different things. It'll do tension, compression. It'll do brake testing, cycling. It'll do load averaging, peel test. Pretty much anything you get inside
just depending on the
anything
fixture.
that you can fit in between these two things, basically you can test it.
Okay.
And that's one of the neat features about the system. As a force measurement system, we offer 4 different style of load cells. So it basically gives the customer the ability to choose what they want to do. For example, if you were doing spring testing, you would not want to go with an S-beam load cell because, as you know, when you're compressing a spring, it tends to want to twist.
Right.
And the S-styles don't really do well with that. So we have a round circular load cell that does that application.
Okay.
Some of the other features we went with on here is we went with rare earth magnets instead of the traditional micro switch for the end limits to keep it from going either all the way up or all the way down.
Okay.
Okay. The entire system is based off a tablet. The tablet's kind of unique into the industry, and no one's done it before. And the main reason why we went with the tablet is most of the people in force measurement, Dirk, are trying to get to a computer. As in your earlier segment, you were talking about statistics.
Right.
They want to go ahead and take the data, and they want to statistically analyze the data. Where's my trends falling?
Right.
Okay. With the tablet, I've already can do that. It's dumping the data right into the tablet. It gives me the ability to work directly with Excel or any of the other software packs on the market.
So normally would they do all that with the tablet remaining in the machine, or would they perhaps take the tablet out and take it somewhere, or?
No, sir. It's set up to work directly with the internet. It's got a Wi-Fi. All our tablets are Wi-Fi. Okay. Or you can directly hook it to the Ethernet and hook it right onto your network. So it's another computer on your network.
Okay. So essentially, then what you've really done is rather than have a separate, kind of a big box or even a laptop or something like that, you've just gone with basically using the tablet as a small computer.
That's correct.
And also your display. I mean, it's kind of everything in one.
That's correct.
That's the reason for it. Okay. Okay.
So basically, we're using a full USB connection between the frame and the tablet, and we're getting about 1,000 samples a second between the two. So we're getting quite an amount of data that we can analyze and go back and look at. Okay. What we've got set up here is we've got basically a standard wire tie that we'd use. Nylon wire tie. Okay. And if you have a second, I'd like to just go over the front display here to show you what you're looking at.
Yeah, we can go to the gauge cam here.
If you go to, yes. You have the L for load and D for distance. The system will also allow you to measure height as you see the H come up. So I can cycle between height or distance. Okay. The difference between it is on height mode, Dirk, you're looking at from the bottom up. Okay. So this being your 0 point. on a distance which is set up for now, I can hit 0 and the distance will be measured from this point either direction.
Okay.
So by hitting the jog wheel, I can make it run up or down.
Okay.
Going over just a real quick test, and this is really the heart and the soul of the system, is how easy it is for people to come in that have never used the system and actually write a program. Okay. If I come down here, I click New Test, and I go to Break Test, because that's what we want to do. We want to actually break this wire tie. It asks me some real basic, basically 4 different things. It asks me some real basic questions. As in any test method, you want to go ahead and zero out your load and your distance because that's where you're starting from. Over here where I see Set Home, I'm basically saying at the end of the test, I want you to come back to this position, okay? Here's our actual test. We have 2 different directions we go, tension being up or compression being down. Obviously this test is set up to be a tension test.
Okay.
So it asks me a minimum break. And what this is the starting point of where you want the break detector to start looking for a change.
Okay.
Okay? So on this particular wire tie, let's just say 2 pounds. Break is actually the percent from the max load or peak and how far you want it to fall down. Okay? And that means how far do you want it to drop from peak.
Okay.
So for this one here, let's just say 50%, just keep it simple. And we'll say 50%. If you noticed, I'm just inputting this on the tablet on the bottom down here.
Okay, gotcha.
Speed is relative. Most things that you test have a ASTM or spec already written to it, and it tells you what speed you would run at.
Okay.
So for this test, let's just keep it simple and say 10 inches a minute. As I set home up here, I want it to go ahead and return home at the end of the test. So again, it's going to come back to where the set home position was. This is all I have to do to create a test. So you can see.
And you could save that as a test, something you could just recall later?
That's what we're doing right now.
Okay.
So all I've got to do is hit the Done button. Okay. As in any standard practice, I want to come up, zero my load, zero my distance. To start the test, I click Start Test. So it's pretty obvious. As you can see, the crosshead's going up at a controlled 10 inches a minute. And eventually it broke.
It snaps, okay.
The wire test. And here's where it was. So that wire tie actually was 40.38 pounds. This is the distance it went, and this is where it broke. Obviously, you noticed when I put in 50%, this is 50% of that.
Oh, okay, okay.
Okay, and that's the drop.
But this is the actual, that top, your M load, that 40.38.
Is the peak load or the maximum load that
so that's
achieved.
actually where it broke?
No, sir.
Okay.
Everything has to go ahead and reach a maximum and then yield. Okay. The only thing that does almost both at the same time is glass, okay, or ceramics. But in this one here, it has to yield to break. I can prove that by my graph over here. Here you can see the load being applied.
Okay.
Okay. This has gone from this point here. If I would have returned the test, it would have went back to its original shape. What happened here is it went from its elastic region to its plastic region. Okay. And you can tell that by notice the load. Notice the load doesn't go up anymore.
Right. It's because
but
it's
the
stretching.
distance is traveling. So that's basically showing you it's in its plastic region.
Okay.
So here was our peak right here, and then you see it starting to tail down as it goes down, and then it drops. Okay. So that basically shows you the tail of the tape of what happened during our test. Right. So we went from elastic to plastic, and then it had a long distance in between, and then it started to tail off, and then finally broke. Okay. So it's a very nice feature to have on there. One of the other things that we offer on here is we do have our statistics. So it gives us all our data tying into your earlier segment. It's collecting all this data for us. So if we put on another wire tie and ran another test, very simple, quick change. I put the wire tie back on. As you notice, it's not
pretty easy. Okay.
Okay. Come back here to my load and distance. The only thing I have to do now is hit Start Test. So it's pulling the wire tie, as you can see. There we go.
And about the same numbers.
About the same numbers, but the neat thing about this is I want to know, is it trending the same as the last one? I can do it statistically, or I can do it the lazy man way and go in and actually go ahead and hit the overlay on the graph. So there's our first one, number 1, and here's number 2. So now I can see, is it trending the same, yes or no? So it's a very easy.
And you could keep stacking. It'll just keep adding.
That's correct, Dirk. It'll just keep adding another dot and another overlay. Okay. And you can really trend it out and see what you're seeing on the screen. So it makes it very, very simple for an operator to quickly see, am I in spec or am I not?
And what's the capacity on this? You said 250?
1,000 newtons is equivalent to 225 pounds.
Okay. And is this the largest unit, or?
No, sir. We have 7 different models now.
Okay.
Okay, starting from 500 newtons, which is equivalent to 110 pounds, to our 1,100 or 1,000 newtons here, which is 225 pounds.
Okay. And they're all the same form factor, but maybe a little smaller, a little bigger, that sort of thing? I mean,
up to the 5 kilonewtons, we keep the exact same format, same look and feel.
okay.
Over 5 kilonewtons, we go into our 10 kilonewton, 30 kilonewton, 50 kilonewton format, which are twin columns. Obviously, the load on a single column makes it flex, so you end up going with the twins.
Okay, gotcha.
So it's really a robust design on the single and the twins.
Okay. Well, Eric, thanks. If anybody wants more information on the FMS-1000, there actually is a link on the bottom of the player page there. If you click that, it will actually take you out, I believe, to the landing page for the FMS-1000. I think on that page there's also links to the other models as well. So, Eric, thanks for joining us on the show.
Thank you.
Thank you, guys.